Hello everyone. In this video I'll explain another very popular sorting algorithm and the name is quick sort. So just like merge sort, quick sort also follows divide and conquer approach. Therefore, the array is split into sub-arrays and these sub-arrays are recursively called to sort the elements. Now in case of quick sort, it just picks an element as pivot and partitions the given array around the pivot point. Now there are different ways to pick the pivot. We can select the first element as pivot, or we can select the last element as pivot. Then we can also randomly select an element as pivot or take median as a pivot. So depending on the ways of selecting the pivot, the program for quick sort will also be different. So now let's see how does it work. Since it's a divide and conquer approach, let's see what happens in all these steps. So for the divide step, the array is divided into subparts taking pivot as partitioning point. The elements smaller than the pivot are placed to the left of a pivot and the elements greater than a pivot are placed to the right. For the conquer step, the left and right subparts are again partitioned into by selecting pivot element for them. This can be achieved by recursively passing the subparts into the algorithm. The combine step is not so prominent in case of quick sort. This step does not play a significant role. The array is already sorted at the end of conquer step. So let's see a simple diagram where we can see the array is there, and here we are taking the last element as our pivot point. So all the points, those are smaller than this pivot point, will be separated into the left side, and the all points or numbers greater than this pivot point will be partitioned into the right side. So every time a pivot point will be selected for the sub-arrays and the process will be keep continuing. So let's see how we can implement it programmatically. So first a pointer is fixed at the pivot element. The pivot element is compared with the elements beginning from the first index. If the element greater than the pivot element is reached, a second pointer is set for that element. Now the pivot element is compared with the other elements like the third pointer. Then if an element smaller than a pivot element is reached, the smaller element is swapped with the greater element found earlier. The process goes on until the second last element is reached. Finally, the pivot element is swapped with the second pointer. Next, the left and right subparts of this pivot element are taken for further processing. The subparts are again divided into smaller subparts until each subpart is formed of a single element. At this point, the array is already sorted. So now let's see an example. Here we have an array with 7 elements, and here we are taking the last element as our pivot point. So here pivot is 2. Therefore, our main task is to divide this sub-array. So all the numbers those are smaller than 2 will be in the left side, and all the numbers those are greater than 2 will be in the right side. So to do this whole process, we have to follow these things. First, we are considering a pointer in our pivot element. Next, we are taking the second pointer in the first element, and which is 8. Now we are comparing this first element with the pivot point. Now 8 is greater than 2, so we are just leaving it. Next, but we are still keeping the second pointer there. Next, it's 7. 7 is greater than 2. Next is 6. It's greater than 2, leaving there. Now we find 1. 1 is less than 2. That means 1 is supposed to be in the first position or in the left hand side. Therefore, we will simply swap the position of 1 and 8. So next, after swapping to 1 at the position of 8, that means the first position, we will move to 7. Now again, same process will start. 7 is greater than 2, leave it. 6 is greater than 2, leave it. Next, 0 is less than 2. Therefore, we are simply switching or swapping the value of 0 and 7. So after swapping 0 and 7, 0 comes in the second position, 7 goes there. So next our pointer comes to 6. So again we will compare all these elements with the pivot point 2. So after comparing, we find that all elements are greater than 2. That means the intended position for the pivot point is the place of 6. That's why we will swap the position of 2 and the 6. So after this pass, we finally move the pivot point to its intended position, and all the elements, those are smaller than the pivot item or element, are in the left hand side, and all the numbers, those are greater than 2, are in the right hand side. So after that, we will just split that array in point of 2. So after dividing the array, we get two subparts, one consisting of 1 and 0 and the other consisting of 8, 7, 9, 6. So again we will repeat this step for this sub array. We will take 0 as pivot point, then we will sort this sub array. Here we will take 6 as the pivot point, and we'll again do the same process and we'll bring it to its correct position. Then we will split this again. The same process will keep going on until we split out all these elements into 1 points. So at the end of this whole thing, we get the sorted item. So in the next video, I'll show the program to implement quicksort.